So today we will be talking about induction heating, and we will be comparing um, two very popular Chinese ZVS based induction heating modules that are very popular. They are sold on Amazon, they're sold everywhere you can search for them. They're very popular and they do not seem to do the job the way they should. What I mean by that is that they are not efficient, and that is probably due to their low frequency of operations. You see, induction heating works by inducing through the electromagnetic field generated by the induction coil eddy currents inside the ferromagnetic material, and those eddy currents induce Joule heating through the resistance inside the metal, and the metal heats up. So high frequency is key when you want to have an efficient induction heater, and that's what I'm gonna be showcasing today. We're gonna make a little comparison about what's on the market and what capabilities it has and what differences it has with my own induction heater and what difference that has compared to the other two. So let's see. Our first will be this very popular induction heater that runs maximum on 5 to 12 volts DC. So we'll do that. We'll give it 5 volts DC. Actually 12 volts DC. With me. So we're seeing here at my power supply it's drawing 3 amps at 12 volts. So let's see what happens. How fast is the blade gonna go red hot? Okay. I do take that as red hot, but that surely is hot. Those MOSFETs are almost ready to be blown. So let's pause and go to the next one. Let's check this oscillator. It's rated at 12 to 30 volts input. Wow, 12 volts input, huh? Yeah. Let's do that. Let's go to... Oh, no. My power supply doesn't like. See? Pause. So now we have this module that supposedly is more powerful than the last one. So let's give it 12 volts. Don't see much of induction heating going on. Be honest, the only thing heating up is my MOSFETs. Yeah, that's no bueno for me. Yeah, guys, I do not see any. The MOSFETs are hot. That's nothing. Induction heating module.
Σταμάτησε το.
Now let's check my own induction heater and see how it goes. Now, I believe the difference is obvious to anyone watching what the higher frequency does to the metal. So what I'm trying to say in this video is that induction heating is not as simple as putting two yellow ferrite power inductors and two capacitors as the Chinese ones are being sold. It's more about the switching frequency of the oscillator and not the raw power that you can push through it. So I'll leave you with that thought that the higher the frequency, the faster the magnetic fields collapse and the more eddy currents are created inside the metal, heating it up faster. And what that is all about is those two red ferrite low inductance ferrite rings and this low ESR polypropylene capacitor with low capacity. So we have a high frequency of oscillation. That's what heats up the metal fast and keeps it hot while your device remains cool to the touch. So that's all, guys. Like, comment, share and subscribe, and tomorrow we will have a new video about Tesla coils.